Okay guys, so in this video let's talk about the functions of NAD plus and NADP plus. So these are very popular coenzymes. You may find this most often in biosynthesis pathways. Like first I will tell you like in what occasions do we need this NAD plus and NADP plus. Okay, so before I go into the molecule, let's think a structure like this. Okay, here you have a carboxylic group. Okay, here you have a carboxylic group. Let's say in biosynthesis pathway you have a reaction like this. So here you have a carbon and it has turned to OH. So this reaction can be in equilibrium like this. Okay, so both ways are possible. So the first thing is, in simple organic chemistry we know exactly how to reduce this carbonyl group into a hydroxyl group, right? So it's pretty much easy. We can use lithium aluminum hydrides. Likewise, we can use simple reagents to do this particular reaction. But in biosynthesis pathways, the enzymes are the main compounds, main reagents which are driving the reaction forward. So in this case, this equilibrium, right? This equilibrium driven by this NAD plus or NADP plus. So this is the structure, right? This is the structure for NAD plus and NADP plus. There's a small difference for NAD plus. You can see here there's a R group. Here, look at this. Here you can see a R group. For NAD plus, this R represented by hydrogen. If you see this molecule with a hydrogen instead of R, which means it's a NAD plus. If it's NADP plus, which means this R group represented by phosphorus. Instead of R, there's a phosphorus in it. Okay, so this is the structure of NAD plus or NADP plus. You can see there's a plus over here. There's a plus over here. So this plus charge can be neutralized by accepting a hydrogen atom. So with that we have, let me take my color. Okay, NADH or NADPH. So here in this case you can see here, when we have carbonyl, right? When we have carbonyl, to convert it into a hydroxyl group, we need to provide the proton, right? We need to provide a proton. So in this case we need to use NADH or NADPH. There should be a H, so it can provide a proton to our carbonyl group. When it comes to here, right, when it comes to like when you have to convert the hydroxyl group into the carbonyl group in biosynthesis, okay, you need to take out this proton, right? You need to take out this hydrogen. So in this case you need to add NAD plus or NADP plus. Okay, so we will talk about the mechanism, like how this proton donation or proton acceptor happens. Okay, so for now I need you to understand these two main things. First of all, this is the NAD plus and NADP plus structure, how these two vary from each. It's only by the simple hydrogen atom and phosphorus atom. That's how these two are varied. And in what occasions we use this NAD plus and NADP plus. This is very important. Okay, this is very important. So when you have a carbonyl group in biosynthesis methods, when it convert into a hydroxyl group, it surely there should be a NADH or NADPH, because the hydrogen is being added. When the hydrogen is removed, you need NAD plus or NADP plus. I hope you have that particular thing in your understanding. Okay, so let's move forward to the mechanism. Okay, let's go to the mechanism. So for the practical simplicity, okay, for the it's so hard to draw this whole structure, right? So I will take this whole part here. I will go with NAD, okay, NAD plus. So I will take this whole part as R group. Okay, this whole part is a R group. So I will now draw the structure with it. So here we have the nitrogen on it, CONH2. Okay, I'm drawing this one. Okay, I'm drawing this one. So here you have CONH2, and here you have this one, this one, and this one, and you have a plus charge. So it is connected to this whole R group. Okay, this whole R group I have represented simply. Okay, so let's take NAD plus. This is the NAD plus. Okay, now let's assume you have a carboxyl group, OH, just like this. You have a hydroxyl group. Okay, when you have a hydroxyl group, what happens is, okay, this, let me take a blue color. Okay, what happens is this bond over here, okay, this bond over here. Oh, okay, I will start with here. So this bond, okay, this bond will be attacked to this particular position, which result in the shifting of this pi bond to this place, and now this pi bond is converted into a valence two electron pairs. So now with this happen, you can see this carbon is less on electron, right? It needs electron. So this bond broken, this bond is being broken with the hydrogen is removing. So this particular electrons donate its electron density to form a pi bond between the carbon and oxygen. Now you can see in this case NAD plus act as a hydrogen acceptor. It accepts this hydrogen, not this hydrogen. Okay, not this hydrogen. It accepts the hydrogen on the carbon. That's the more important thing. With that, you will have your product, the neutral product. You have a nitrogen, you have R, and now you have a lone pair, and you have a hydrogen on here. With that, you have a double bond here, and you have a double bond here. There is CONH2. Okay, this is the case for NAD plus. So let's say the otherwise. So we have talked about how the hydroxyl is converted into a carbonyl group. Here you can see now with this one, you have now carbonyl group. You now have a carbonyl group. Now let's see how the carbonyl group, okay, how this carbonyl group is going towards the hydroxyl group, right? Okay, let's look at that. So I will again take this NAD. Okay, now I have NADH. You know, like now when the carbonyl group is to be converted into a hydroxyl group, you need the hydrogen to be donated. So now you need a NADH. You need the hydrogen on it. Otherwise, you cannot donate it, right? So here you have the structure of NADH. Okay, now what happens is, okay, now you have the carbonyl group. Let's take it like this. Here you have the carbonyl group. You have a hydrogen. There's two hydrogen, right? This is a sp3 carbon. I will only mention one hydrogen. So now the reverse, right? The opposite of this particular mechanism. Now this lone pair will donate its electron density to this nitrogen and carbon to form a pi bond. Because of that, this carbon will get unstable. So this double bond will move here. Okay. Because of that, this carbon is going to be unstable. So this particular bond will donate its electron density towards our carbonyl sector. So with that, this pi bond is going to be broken. It will donate its electron density towards a proton. Okay. Now we have our structure, our NADH. Now this NADH have donated its hydrogen to our carbonyl center, right? Okay, now this is not NADH, the H is missing now. So now we have NAD plus. Here we have the NAD plus. And we have the carbonyl. Here this carbonyl is being converted into a hydroxyl group. So this is the mechanism. So this is the mechanism for NAD plus and NADH. So it's the same thing happens with NADPH, NADP plus, NADPH. Both are same. Yeah, I have told you the difference, right? Only this R group is varying. Only this R group is changed between the NAD plus and NADP plus. So this is the basic. This is the basic mechanism for NAD plus and NADP plus, how it functions on your biosynthesis methods. I hope you get that idea. This is very important. It's NAD plus and NADP plus. How this affects your biosynthesis methods. These are important. Like I don't expect you to memorize this whole structure. If you can, it's a very good thing, because NAD plus and NADP plus are, these two are like very important coenzymes, right? In biological systems, in biochemistry, these are very important coenzymes. So if you can memorize this structure, it's very good. But I don't think in exams you will be asked to draw the structure of NAD plus or NADP plus. But you need to have the idea about that. If the question is given, if the question is given, like the structure is given to you, and you are asked what is the importance of this R group, and what is the importance of this plus group. If the structure is given to you, then you must be able to like propose the synthesis pathway, propose the mechanism. You must have the knowledge for that. So that's the whole thing about this NAD plus and NADP plus. I hope you have the idea about it now. So it's basically this very small thing, not a big deal, but be very careful. Like this is the most important thing. This is the most important thing. Be very careful about this. You need to have the very good idea about this particular reaction system.